I want to know what was the errors of all your results experimental, because any errors I don't find in your results. What was the error? The same as the value, or rather less. You're a physicist, you must show the in mathematics very strong results with error. And all your results without errors. Some last pictures with results you show. In mass spectrometer, in excess heat. What was the error of even?
So who's going to answer? Are you going to answer?
Nobody.
Or from Greece?
I'm not available for this answer. Say okay. Hello?
Yeah, thanks.
I'm Hadjichristos, the technical chief executive of Defkalion Green Technologies. Good question. There are two kinds of measurement of errors: systematic errors and experimental errors. We do have identified the systematic errors in our measurements, and we try to avoid them at a certain level that we provide evidence that calorimetric results are not influenced by them. As we measured, all of the errors that we could estimate were less than 1%. And that was done in third party testing we performed, which really gave us that result. No more than this percentage of errors in calorimetry. On the other hand, there were errors related with noise. As far as this environment of the reactor is very, very difficult to measure, especially inside in the chamber of the reactor. Still, we don't know some elements, some measurements related with what's going on inside the reactor, and we'll work on that. I think that is the question raised.
Okay, we'll go to the next question, please. Mr. Kim.
I'm Young Kim from Purdue University. I talked to you, I guess I don't know your first name, but Young Kim. I talked to you last week about your data. One of the slides shows only even nickel nucleus is capable of doing nuclear reaction, while the hot nickel nuclei do not. Is that experimental fact, or just so what kind of experiment did you do to get that result?
That's experimental the result. Actually, what we did in the beginning, we triggered the reaction only with pure isotopic relation samples, and we noticed that the nickel 58, 60, 62, and 64 can participate, even though samples with like 50, 61 do not participate. So this is an experimental, that's not theoretical. I suppose that your work on volume statistics can give us a good explanation why this happens.
That fact seems very important, because there are two consequences with that result. First one is your midpoint error cannot distinguish even nuclei from hot nuclei. So you may have to modify your midpoint error scenario to overcome quorum error. Second is if the only even nickel nucleus react, there cannot be many theories about it. My Bose-Einstein condensate theory, of course, would predict this in one of my preference, and I think you are aware of that already. But it's very important that this is independently confirmed so that theory can be built upon. Thank you.
Thank you, Dr.
What experimental evidence exists that supports that Rydberg state hydrogen is involved? Independent spectrographic evidence or any other experimental evidence of the Rydberg state?
Good question. Actually, to remember, we had this chance to get support from labs, specialized labs in the Defkalion Center. This is the nuclear center in Greece, experimental nuclear in Greece. Two of their labs identified that we're dealing with Rydberg state atoms, and that's why we're getting so hard on them, and not talking only about hydrogen atoms.
I'm sorry, what data did they base that on? High-end state transitions in the microwave, or what sort of independent evidence was there of Rydberg state excitation?
Excitation was measured by the results. They did the spectrum analysis on gas fluorometer, and they identified that Rydberg state atoms are produced during this short period of time during our triggering method. That's why we are stating that the Rydberg state atoms are involved. And this is consistent of the results that we get from the experiments.
Okay, now let's go to the next question. Please identify yourself because from Greece they cannot see us.
Yes. I again state my name is Hadjichristos. I'm the Chief Technical Officer of Defkalion, actually in head of our R&D team. What Mr. Menelos is presenting is the teamwork job, and I'm just the one that manages this team.
John, this is Andrew Muhlenberg from University of Science, Malaysia. One of the slides showed the elemental composition and the changes. I noticed that a lot of the elements went down very, very low levels. Was there any indication that some of these might be critical in the nuclear active environment, and if it become depleted, you might stop, or the reaction might slow down? Any indication of dependence on that?
No, I cannot really reveal what is going on there. We're going to, yes, there are specific elements that if they are not present, then this transmutation does not occur. We will present this data and also the ICD-MS results supporting huge abundances in isotopic transmutation. Later on, when we will finish with the next step. We just show you the indication list there, and not the actual data. We will release this data, and these data also are available for processing by third parties in our lab.
Excellent. Is there availability of these slides that we can look at later?
Not.
Okay,
Not
later.
really. We are welcome in Vancouver, where we're going to place our main R&D facilities from the next week, or in Greece, also supporting R&D, or in Switzerland, work for us on this issue.
You'll be in Vancouver next week?
We're setting up a new lab in Vancouver, where we're moving our major activities, and also part of the R&D process that we're supporting. We will be available for third parties, inspections or visits by the end of September.
Thank you.
Okay, thank you. Go to the next question.
My name is Rami, and we meet every week last week. So my question is a side question, but can be interesting anyway. So you told me privately that after the talk of our group at the Siena meeting, also your group tested the value of carbon nickel alloy in your product. but we have an opportunity to go in details about your results. Can you able to describe shortly what you get with material similar to our and Java group? Thank you.
Thank you, Dr. Celani. It was a pleasure meeting you and I. As I told you literally there, we had the chance to check one of their Constantine alloy that you use and see if we get any higher performance on that. Actually, the result was positive. We got something like 300 watts, the maximum we got, using our reactor with our triggering mechanism. But we consider the result very poor in order to concentrate on that. As already you know, you are welcome to our labs to see the results and of course to cooperate in the field as far as I understand, also anomalies that you observe in electrostatic or magnetic fields are very much closely related to the phenomena that we all try to understand.
Okay, just a small question. How much the amount of active material in your reactor with constant material? How many grams?
We use 2 grams.
Thank you.
Thank you. Go to the next question. Over there.
My name is Dan Chomsky. I'm an independent scholar from California. And I noticed that in your presentation here, you were talking about the gamma rays being absorbed by high energy electrons. Let's get away from where they're being absorbed and take a look maybe at the process that is absorbing and emitting electromagnetic energy at any temperature. This is theory of heat, black body radiation. Because if you have a black body radiation curve that is far from equilibrium, it is absorbing and emitting all of these energies all of the time, and the gamma rays, I imagine, would be masked if they were absorbed into that black body radiation curve. It would have to be a very far from equilibrium black body radiation curve. The electrons that you're talking about, exactly how do they absorb the gamma energies? I don't know if electrons can absorb those gamma energies. They're too high.
Actually, that is speculation. As Mr. Menellos stated, this is our explanation why gamma emission from the triggered reaction do not occur. We are not certain that this really happens, but the evidence we have is that the LW theory might not be completely wrong, could be somehow strong in this area, is the evidence we get from the transmutations. As you noticed, we got lithium, beryllium, and boron not present before the reaction. From ICCPMS analysis we got afterwards. Really, the understanding of why this would happen give us an explanation that this is related with the third phase of our reaction, where we speculate that the gamma absorption is done by heavy elements. We don't have any other theory in the field, or any other theory resulting to these transmutations and gamma emission. So there is room for more theoretical analysis on that, and we will be happy to cooperate on this area.
I bring this up even is that in one experiment you will produce a certain group of transmutation products, I suppose, and in another experiment with, let's say, a palladium as opposed to a nickel electrode, will produce a much different set. And these mass changes in the nuclei all represent a gamma intensity or gamma energy that has to be absorbed somehow. So I'm suggesting the black body form as a form that absorbs and emits all energies within its spectral range.
That would be a good explanation, but this does not really result from what we measure. We have strong evidence, and that's why we speculate on this procedure with heavy elements. We still don't know if they are involved. We need more cooperation on the field compete with other labs that really are more specialized than us in supporting this part of the field.
Okay.
Larry Forsley, you mentioned in there that you saw no gamma rays below 50 keV and none above 300 keV, but you said nothing about what you saw in between. Did you see gamma rays between 50 and 300?
Yes, we got sparks for occasional sparks of energy, low energy that we measure in this area. Actually, at the final energy, it was less than 0.2 ms per hour.
Takahashi from Technology Corporation Japan. As I understood your process of experiment, you first made a plasma discharge for changing liquid state into some porous liquid. And then you used some agent like magnesium or zirconium. And could you show us if you have data by 10 or 10, even 10? What is the composite state of nickel, porous nickel, and agent material, ceramics, magnesium, and zirconium, and so on? Could you show us that data? Very important.
Yeah, it is important. It is, as you all understand, it is related with the IP protection patents we are placing this, and we are preparing this period of time. We are going to reveal the geometries of the agents around the nickel. They are not only zirconia or magnesia or the zinc oxide, there are other agents involved. We mentioned these three. They are agents, and they are coated on silica, aluminium, and ceramics.
I think you need to disclose that's right, to promote the science very open and developed.
As you remember, in MI, they have an open invitation for cooperation in our labs.
Okay, thank you. Because you cannot ask questions because the people answering questions is in Greece, so we are going to stretch out a little bit. So, yeah.
Is the mic on? Dave Kidwell at the Naval Research Lab in Washington. Can we go back to the radiation that you mentioned? How was that measured?
It was measured with a potassium iodine sensor. Logged with the same log with the rest of our data acquisition.
This was a 5-inch sodium iodide detector?
Correct. You have seen a photograph of that we presented.
Okay, thank you.
Okay, any other question, comment?
If there are not any other questions, I would like to make the final statement, if you please.
Okay, go ahead.
We would like to first of all thank all the scientific community of ANR, which is still very small and under budget, and we hope that you all will play a very important role from now on. That's why we opened a cooperation discussion indicating the strong need of two things. One is a more robust and straightforward definition of what these phenomena are. And also the second one is that we have to really think very seriously about the industrialization part. Industrialization doesn't mean setting up only production line. It means that there will going to be a body defining tests, standards, and science is going to support science. We cannot rely on nuclear atomic committees around the world or the chemical committees as far as these phenomena are not classical nuclear phenomena or chemical phenomena. There might be something in between. So the open invitation we do through this presentation of our company to this small society that is there in ICCF is to play a role towards that. and we would be happy to support the role of an international independent body on ANR, or whatever you call it, supporting that financially as the industry, or one of the industries of this sector. And we would like to thank you all for the opportunity you gave to us to present to you our first line of data in public.
Okay, thank you. I think we